when you're solving absolute value inequalities, you're going to use the skills that you learned back in chapter 1, solving absolute value equations, combined with what you learned about compound inequalities just recently, and put those together and reason out how can I find the solutions for compound inequalities that have absolute value expressions in them. So first of all, let's be reminded, what does absolute value mean? What is absolute value? Ricky?
It means like there's two solutions. It can go either way, negative or positive, but it has to be like the same distance from zero.
Okay, so I will agree with you that there can be two solutions sometimes.
Alright, but not always, because like if it's a negative on the other side of the equal sign, it's no solution.
Okay, but we still haven't said then really truly what is absolute value. You told me something about solutions when you have some absolute value involved in it, but we still haven't defined what does absolute value mean. What is absolute value?
The word, like how much the number is worth.
How much the number is
From the zero.
from zero. So it's distance from zero. When I ask you for the absolute value of 5, what you're really being asked is how many units away from 0 is 5?
5.
5. If I ask you for the absolute value of negative 10, I'm really asking you for how far away from 0 is negative 10? 10 units. So distances, we never talk about distance being what?
With the symbol.
No.
With the, like,
Distance, negative. We don't measure distance in negative numbers. We only measure distance as 0, I don't go anywhere, or we measure distance as a positive value. We don't ever have negative distance. So those are things that we learned, believe it or not, back in chapter 1. Okay, now we're going to keep that in mind while we're solving these. We're going to have two situations. We're going to have when inequalities involve the is less than and the is less than or equal to symbols. If it has one of those two inequality symbols, we should be able to kind of have the same thought process throughout. Okay, so the absolute value of x, remember absolute value bars are those two vertical line segments on either side of an expression. The absolute value of x is less than or equal to 2 says that x must have a distance of no more than how many units?
So 2 negative. That one. Also.
Absolute value of x is less than or equal to 2.
Anything less than or equal to 2.
It says it can't have a distance of anything more than 2. So it can't be any more than 2 units away from 0. So give me some examples of some values we could put in there for x and it would satisfy that inequality. And it would, in other words, it would be no more than 2 units away from 0. Christian?
1.9.
1.9. Paul? 1. Ricky?
0.
0. Riley?
1.
Somebody gave that one already. Morgan? 0.5. Isaiah?
1.6.
Okay, so far I've gotten 0 and a bunch of positive numbers. Michaela? Pardon? Negative 4?
Negative 1.
Negative 1. Okay. Ricky?
Negative infinity.
Okay, negative infinity is negative infinity less than or equal to 2 units of distance from 0?
Yeah.
No.
In fact, give me some numbers that would not satisfy that. We think negative infinity wouldn't, but Ricky's still convinced it would. So let's give him some of that other ones that would. Ian?
3.
3. 3 is 3 units away from 0. Is 3 less than or equal to 2? No. Okay, Isaiah?
1600.
1600. 1600 is 1600 units away from 0. Is 1600 less than or equal to 2?
Just kidding.
No. Michaela?
1. Negative
Negative 3. What's negative 3's distance?
3 away from
3 is 3 away from 0. Is 3 less than or equal to 2?
Alright.
So there's a range of values that's kind of sounding like there's something that can't go out any further than how far to the left?
Negative 2.
Negative 2. And it can't go out any further than
2.
positive 2. This is looking like what kind of a compound inequality? An and. Yeah, so we're going to write it as a be able to get rid of the absolute value bars. We say x has to lie between negative 2 and positive 2. It includes those, so I can have an equal to bar. And then x has to be, when I read it from the inside out, x has to be greater than or equal to -2. And x has to be less than or equal to +2. It has to be sandwiched, all the values you pick for x are sandwiched into the region. Anything outside of it would make that inequality true. So we would consider this to be the solution for x is, the absolute value of x is less than or equal to 2.
I need to graph that out.
And we are going to graph it when we start solving it, but this is just kind of like showing us how we get there. Okay, let's start solving. We have the absolute value of x. Being subtracted from that is 7. That is supposed to be less than or equal to -3. Michaela?
Add 7 to -3 and 7.
Yeah, this is like solving our absolute value equations. We need to do step A, where in step A we have to get the absolute value expression by itself first. So we have the absolute value of x now by itself is less than or equal to 4. That's step A. Unless we're not done with step A. Are we done with step A? Yeah, the absolute value expression doesn't have anything else going on outside of it, does it? Okay, now we're ready to move on to step B, and in step B, this is when we ditch the absolute value bars and set up any situation that will help us get the values for x that are in the solution set. So this is what this says. X has to have a distance of less than or equal to 4. Any number you want to be in the solution set has to have a distance of 4 or less. So what would that look like? Or is there a range again? It goes out how far to the left? -4. It goes out how far to the right? +4. This would be a compound and inequality again, wouldn't it? So we're going to say x, we ditch the absolute value bars, has to be greater than or equal to -4 and less than or equal to +4. Those are the only numbers that have a distance of 4 or less. Okay, and now we will graph that solution. So that's our solution, and here's our graph. And this will be just like what we've been doing for the last couple of days. Any number in the shaded region put back into the original inequality will make it true. Any number outside of that shaded region would make it false. Isaiah?
If we graph it like this and we put an open circle at 5 and an open circle at -5 and shade everything in there, would that be okay?
That would be wrong because 4 and a fourth is not a solution. Right? That's why we work with endpoints and we either leave them open or shade them. We've got to have our endpoints, okay? Does that make sense? Okay, let's just check ourselves out here. Let's make sure we know what we're doing. Let's pick a number out here to the left of -4 that's not in the shaded region.
-10.
-10. Let's go put it back into our inequality and see what happens. When we take -10's distance, what do we get? 10. The distance of -10, we put -10 in for x, that's 10. 10 take away 7. 3. Is 3 less than or equal to -3? No, it's greater than, isn't it? Okay, and it shouldn't make it true. It's not in our solution region. Okay, let's pick another one that's over on the other side, outside of the solution region in the positive territory. Hunter, give me a number.
Outside of it?
Mm-hmm.
-5.
No, I wanted it outside in positive territory. Thanks for being engaged. 5. Okay. Absolute value of 5. 5's distance is? How far is 5 from 0? 5 units. 5 take away 7. -2. Is -2 less than -3? Equal to -3? No, neither. So it should not be in the solution region. But all our shaded ones should be. If we put -4 in there, it better make it true. If we put +4 in there, it better make it true. If we put any numbers that are in between there, better make it true. Okay? Okay, let's look at the next one. Do we need to do step A? Is the absolute value of 2x by itself right now on that side? No, we need to do step A. Step A says you better get the absolute value expression by itself. And that 5 is not inside those absolute value bars. So we have the absolute value of 2x, now it's alone, is less than 6. Now, as tempting as it's going to be right now, to divide everything by 2, we're not ready to do that yet. We have to get rid of those absolute value bars first. This says 2x has to have a distance of less than 6 units. 2x has to have a distance of less than 6 units. So, give me some examples of some numbers that have a distance of less than 6.
3.
3. Ricky?
-5.
-5. 5.
4.
2. 4.
5.9.
4.5.
Okay, how about 10?
No.
No. How about 7?
No.
How about 6?
No.
No. So 6 though would be up to 6, right? Would any number up to 6 is not here like a 5.9 or something?
5.9.
Any number up to 6 and any number down to -6. So we're going to say -6 is less than, but we don't want the equal to bar this time, do we? Because we don't want to include -6. It doesn't have a distance of less than 6. 2x, what's inside our absolute value bars is in our middle region, is less than 6. That's how we get rid of the absolute value bars. We are right now in step B. And now we're ready to solve it by doing what? Dividing by 2. So we're going to take every piece and divide by 2. And our solution will be -3 is less than x, and x is less than 3. And then we'll graph it. We'll show what are all the values x could be that would make the original inequality true. Now be careful, don't let your brain do this. The endpoints will always be opposites of each other. Because that's what's happened so far, hasn't it? Yeah, let's see what happens in our next one. Anybody have questions about this one that you still are unclear about? Okay, let's decide then in the next one, do we need to do step A? No, it's already by itself. We get to skip step A and go directly to step B. Step B says ditch those absolute value bars. 2x minus 4, that expression has to have a distance of what, Christian?
4.
No.
10.
10 or?
Or 10 or -10.
10 or distance. We're only talking about distance right now. Ian?
More or equal to?
More than 10? 10 or more?
10 or equal to.
10 or, that's the equal to part. 10 or
Less.
less. It says is less than or equal to 10. So 2x minus 4 has to have a distance of 10 or less. So where are those numbers at? Where are those numbers that have a distance of 10 or less? Where are they at on the number line, Ricky?
Everything in between 10, including 10, and -10, including 10.
Okay, so everything between -10 and 10 inclusive. Is that a short way to say that, right? So we're going to say -10 at this end, because that's on the number line, that's to the left, is less than or equal to our 2x take away 4. We ditch the absolute value bars, is less than or equal to our positive 10. And now we're ready to solve this. And this is what we've been doing before this, right? What would be our first move? Adding 4 to every Region, adding 4 to every region. So we're gonna add 4 in each region. Go ahead and finish solving it, because you know how. You get the same solution I did.
Yep.
Okay. Are endpoints opposites this time? No, they're not, are they? So we can't assume that the endpoints should end up opposites of each other. And now we will graph it. We will show all of the numbers that x can be to make this inequality true. They lie between -3 and 7, inclusive. So again, if you picked a number from that shaded region, it better make the original inequality true, or something's wrong. If you pick a number outside of that region, it better make the inequality, the original inequality, with the absolute value bar still in it, it better make it false, or something went wrong. Okay, any questions about that one? Here we got one more we're going to do on this side. We have the absolute value of x, to which 5 is being added, and that is supposed to be less than 3. Do we need to do step A?
Yes.
Okay. What are we going to do?
Subtract 5.
Subtract 5 from both sides. And this says x is supposed to have a distance of less than -2 units.
No solution.
Are there any numbers less than -2 that have distance? No. Or can be claimed as distance? I mean, they have distance, but can they be claimed as distance? Do we have negative distance? No, we don't. So since absolute value of a number must be 0 or positive, if you're talking about distance, absolute value is distance, it has to be 0 or positive, and this states that the absolute value must be less than -2. Well, that's not positive, that's not 0. There are no, I think it's, I meant to say here, there are no, no, we'll just say numbers. Oh, no, because it says values there, I can't have that, that doesn't even make sense. Okay, there are no positive or 0. I just didn't leave us a whole lot of room. There are no positive or 0 values less than -2. So what are we going to say? No solution. That's right. This one has no solution.
We have to write all that every time we have a
No,
problem.
no. But this in your notes, you want to know why. Okay. Now, don't let your brain do this. These are not like the absolute value inequalities are not like equations. Just because there's a negative number over there means there's no solution. The reason this one has no solution is because there are no numbers less than -2 with a distance of -2. So we can't talk with, that's what we have to think in this situation. Okay, so these were all, every single one of them we did were either is less than or is less than and equal to. And every time we had what kind of situation did we set up unless there was no solution? What did we set up every time?
And
An and compound inequality, every time. Okay, so now, let's go to the back side. When we have inequalities now that have is greater than, and is greater than or equal to, something else is going to happen. So the absolute value of x is greater than or equal to 5 says that x must have a distance of at least 5 units from 0. Greater than or equal to 5. Your parents say they'll give you at least $5. You know that means they'll give you 5 or more, right? Okay.
Not necessarily.
So at least 5 units from 0. Well, let's think about some of the numbers then that x could be, that are at least 5 units from 0. Morgan, give me one. Cole, give me one. 7. Isaiah.
16.
16, okay. Ricky.
75 million.
75 billion, okay. Michaela. 6.
I said
-6. Well, thank you. Somebody went into negative territory. -6 is at least 5 units from 0. Hunter. -7. Okay, so are you getting the picture?
It's an or.
It's an or, isn't it? Because it could be starting at where on the number line here? On the left. Negative what? What numbers? -5 and less than that are all at least 5 units from 0, aren't they? So let's write that. So x is less than or equal to -5. All those numbers are at least 5 units from 0. And then you guys were naming some positive ones, and I didn't hear anything under 5 named. Because if it's at least 5 units from 0, it has to start at 5 and go up. Yeah, it's gotta go that way. So, look at this. This is, we got it going this way and we got it going that way. What kind of a compound inequality is that? Or. So this is an or. X is greater than or equal to 5. Okay, so that's going to help us set up our step B when we're solving ones that have is greater than or is greater than or equal to. Okay, so let's do the first one here where we have the absolute value of x take away 7 is greater than or equal to -3. We see a negative number on the other side. We don't even let our brain go there yet. We have to do step A.
Yes.
Okay, we have to do step A. So what are we going to do? Add 7. Okay? After we add 7, we're going to have absolute value of x is greater than or equal to 4. That's saying x has to have a distance of at least 4. So step B, what are we going to write in step B? We got to ditch the absolute value bars and write is greater than or equal to 4,
4.
or
X is less than.
x is less than or equal to -4. Yeah, we got -4 and all those guys that have a distance of 4 or more. We've got +4 and all the numbers to its right that have a distance of 4 or more. And so we have our or situation here. Do we have anything to do to solve it? Is it already solved?
No. We have to
Yes.
We have to graph it, but is it solved? Is this our solution?
Yeah.
Yeah, this would be our solution. And now we can graph it to show the values that would make, and again, use the number line properly. Just because the 4 comes first in the first inequality and then the -4, that isn't how we put it on the number line. So, shaded circle to the left of -4, shaded circle at 4 to the right of +4. So questions about that one? Okay, back in chapter 1, we were doing absolute value. I said, never treat absolute value bars like parentheses. This does say 3 times the absolute value of x minus 3. But it does not mean you should do distributive property to get rid of the absolute value bars. So you're going to do step A, which is divide each side by 3. So the left side gets divided by 3, the right side gets divided by 3. Okay, when we have a multiplication problem upstairs with being divided by a number downstairs, we can cancel. We don't cancel that other 3 though, careful. We have a 3 times that, and then that's all one term really, getting divided by 3. We can cancel the 3's, the multiplying 3. So now we have absolute value of x, take away 3. Did we divide by a negative?
Nope.
No, so we don't switch the sign. And 12 divided by 3 is 4. Okay. Go ahead, you do your setup for this now. You do step B. We're done with step A. You see if you can get step B set up. Don't be doing any adding 3 yet. You're just setting it up. You should be setting up a compound or inequality. And that's what it should be. We need all the numbers that have a distance of more than 4.
Oh, this is like the negative one be on the left side.
No, it can be on the other side, like it was in our other one. Yep, that's okay. And then when we have an or compound inequality, we solve them independently, right?
Yep.
Okay, so go ahead and solve now. Now you can add your 3. And then we will wrap it on a number line. Okay, anybody have concerns or questions about that one?
Nope.
Okay, I want you to do step A in our last one here. Over here, it's our last one right here. I want you to do step A. And by the way, there are 2 steps you need to do in step A this time. Did you get the same solution I did? Oh, wait a minute, do I have a solution yet? No, I'm only done with step A. You have the same finished product after step A?
Mhm.
Okay. So is this no solution then?
No,
Why not?
Not yet.
because
But,
you still have to add.
Well, there's the negative number on the other side and the absolute value expression is by itself. I thought,
No,
Because we still have to
just
check.
have to be.
It's gonna be no
like,
solution if you keep
add-
going with it.
Then you add 2 to both sides.
this
and then
says what? What does this actually say?
It's greater than
It
negative.
says that
2.
x plus 2, its distance, has to be greater than or equal to negative 2. Well, it can't be equal to negative 2, can it?
No.
Or can it be greater? Can we find some distance that's greater than negative 2?
Yes.
Yeah.
0.
So starting at 0 and all those other numbers past that, isn't that all positive distance going that way? Okay?
Yeah.
So absolute value has to be positive. And since this includes all the positive numbers, and let's put 0, and let's put, it has to be positive or 0, let's put it here. We always want to include 0, I don't know why I didn't. Absolute value has to be positive or 0. And all the positive numbers and 0 itself are greater than negative 2, aren't they? Every single one of them are greater than negative 2. So we're not saying there aren't any numbers that don't have, we're saying that X can be any number actually.
Any positive number or any number?
Just any number, it can be any number on the real number line, because here's what's gonna happen, you guys. Here's what's going to happen. No matter what number you put in for X, when you, even if it ends up, after you add 2 to it, it's still a negative number. What happens when you take the absolute value of a negative number? You get a positive. Isn't a positive number greater than negative 2?
Yes.
Can you think of any positive number that's not greater than negative 2? No. So it doesn't matter what you end up putting in for X. It doesn't matter. If this ends up negative, when you take its absolute value, it's still going to be positive. When you put in negative 2 for X, you're going to get 0. When you take the absolute value of 0, you're going to get 0, and that's still greater than negative 2. When you put in a positive number and add 2 to it, you're going to get another positive number. When you take the absolute value of a positive number, you're going to get a positive, and that's still greater than negative 2. We can't find anything that when you take its absolute value, it's not going to be greater than negative 2. So that means our solution is all real numbers. So we have to be really careful when we're doing these inequalities. Okay, go ahead, Michaela.
So the difference between all real numbers and no solution is that when it's a negative, the symbol has to be greater than or equal to be all real numbers.
Greater than, or you don't even have to have the equal to bar part.
Well,
So here's the conclusion we're going to make, guys. Here's the conclusion we're going to make. We're going to summarize all of this, okay? Let's go. Absolute value expression, I'm just going to use X as my expression inside of it. When you have an absolute value expression by itself, and it is less than a number, and that number is positive, so in other words, the distance has to be greater than, it has to be less than a positive number. So we said on the front side, that happened, we had an and inequality. And inequality that we set up. It's a compound inequality, the and one. So in our step B, we can do step B and we set up an and inequality. So if it is less than a positive number, that's what we have. When it is less than a negative number, when our a value is negative, that's when we're going to say, you know what, you can't have distance that's negative, so it's going to be no solution. When you have your absolute value expression by itself and it's greater than a number, and that number is positive, that's when you're going to have your or inequality. And when you have your absolute value expression by itself greater than a negative number, all real numbers, because all positive numbers are greater than a negative number. So you have 4 possibilities. You're going to set up an and get a compound and inequality solution. You're going to get a no solution. You're going to set up an or and get an or compound inequality solution, or you're going to get an all real number. Those are the things that should happen in these 9 problems for Monday. So all you have to do is get the assignment written down.